think anymore a war without the use of drones. What we see in the war in Ukraine is that the deployment of drones is massive. And you have there commercial drones, military drones, FPV drones, do-it-yourself drones. It's an arms race that is proceeding really at a very high speed.
Confusion at 4 airports in Denmark last night when drones appeared in their airspace. Flights were grounded, and the investigation into who was in control of that drone, that is ongoing right now.
The rapid spread of drones poses a growing challenge to the security of NATO's airspace. While the alliance is stepping up efforts to counter this threat, the first step before any action can be taken is detection.
Detection and classification of drones, it's important because you want to be able to mitigate only the drone that is posing a threat. In the future, but already in Ukraine you see it, but it's not unthinkable to have a lot of drones operating in the air. You know, Amazon is bringing us packages or drones that are used for search and rescue operations or used by the police for national security. Those drones need to be able to keep flying. You want to neutralize only the malicious drones.
Methods to detect drones include the use of cameras, radar, acoustic detection systems, and by tracking radio frequencies. Radio-controlled drones emit their own radio frequency signature, a kind of fingerprint that links it to its controller. By analysing the signal's characteristics, such as its timing and behaviour across different frequencies, detection systems can distinguish between one model and another. The NATO Science and Technology Organisation has created a database to store these signatures, enabling quicker and more accurate identification of drones.
Here in Aveiro, we are conducting measurements in 3 test sites, at the military base, here at the campus, and at the city center. What makes this measurement really interesting is that we are able to fly the drones in an urban environment.
In an urban area, the challenges are way bigger. So we have more devices, more phones, more buildings, more walls, more trees, which create reflections. In the end, it's more challenging to know what are the drones and what are interferences.
We try to detect and identify signals and try to say which signal is supposed to be there and which might be coming from a drone. So the input is the RF spectrum, which we get from our receiver, and the output is like a detection and classification accuracy.
The group of scientists and researchers will use the data they gather on the different drone signatures to develop, train and test AI algorithms.
We are taking a lot of measurements. You probably heard about these new tools of AI, so ChatGPT and things like that. Well, the process is the same. You have a lot of data, and now we have to train the models to identify patterns of these drones.
The group's goal is to share their drone signature database with all NATO allies. To ensure accuracy, every recording is carefully labelled with information on which drone was transmitting, the frequency, the type of link, and the level of interference present.
One thing that is very important to realize and to remember is that with AI, if you do not have good data, it's garbage in, garbage out, right? I mean, it does not make magic. So it's going to help us a lot, but we need to feed the AI with good data. If we just give them random data, I doubt we will get something useful out of it.
Accurately annotating every signal is essential for training and validating powerful AI models. The result will be tools capable of detecting and classifying a wide range of drones, which will ultimately help NATO allies identify potential threats before they become dangerous.